First, let us see why there is a need to define something called principal branch of an inverse trigonometric function. Before starting to discuss on that, why there is a need? It is because in the previous set of videos I have explained that your function will be invertible, that it is possible to find an inverse for a function only if it is one to one and onto. Are trigonometric functions one to one and onto? No, not at all. For many values of x, you can have one single value of y, that is, it is a many to one function, not a one to one function. Depending on the quadrant in which it lies, you will have a repetition of values of y. Similarly, it is not onto because not all real numbers will have a pre-image in the trigonometric function, that is, we cannot define sine inverse of 2, we cannot define sine inverse of 3 and so on. Therefore, there is a need to make it first one to one and onto to define an inverse on that. That is, we are going to restrict the domain and the range of the inverse trigonometric function in such a way that it becomes one to one and onto. Okay. So, for sine inverse of x, obviously we know that sine function and cos function vary only from -1 to +1. Therefore, the domain is only -1 to +1, and all these values of -1 and +1 can be achieved, can be got by just choosing values between -π/2 to +π/2 for sine and 0 to pi for cos. Why is there a difference? That is because we know that sine of minus theta is minus sin theta, that is, sine is an odd function. Therefore, to get the negative values of the trig ratio, that is, for example, if I have to get negative 1/2 or negative √3/2, or not only the values of the standard angles, even if we have to get negative 1/4, all this can be achieved by just taking a negative sign for the value of theta. Whereas, that is not possible for cos inverse, since cos is an even function, but we know that cos is negative in the second quadrant. So, we can go up to the values from 0 to pi to cover all the values of -1 to +1, which is there in the domain. And tan inverse and cot inverse, both of them have the domain from -infinity to +infinity, and to get those values from -infinity to +infinity, it is enough just we cover values from -π/2 to +π/2. That is because again tan is also an odd function. So, to get the negative values, we just can take a negative sign for theta. And for cot inverse, we are choosing 0 to pi. In the second quadrant, cot is negative, and therefore, if I have to get the negative values, I can go to the second quadrant as well, and cot is defined as cos by sine, and there will be no discontinuity if I choose 0 to pi, since sine of π/2 will still be defined. Whereas, if I choose -π/2 to +π/2, there will be discontinuity there. That is why we are choosing -π/2 to +π/2 for tan inverse and 0 to pi for cot inverse. So, what about cosecant inverse and secant inverse? We know that the domain for sine inverse and cos inverse is -1 to +1. Therefore, those two values, those two intervals, not the values in that interval has to be deleted from the set of real numbers to define the domain for cosecant. Otherwise, we will get a value of sine which is more than 1, which is not possible. That is why we have to delete the values between -1 and +1. And therefore, the range for that is going to be, the range is the same as for sine inverse, except that 0 should be excluded, because cosecant is inverse of sine, that is reciprocal of sine, which is 1 by sine. And if I take x to be 0, then I will have the denominator as 1 by sine 0, which is 0, not defined. And similarly, for secant inverse, the value to be excluded is π/2, since cos of π/2 is 0.